Hello, everyone. My name is Justyna, and it's absolute pleasure to welcome you to Digital Twin DBR77 panel. So before we dive into, let me introduce my teammates, Piotr Wiśniewski, CEO and founder of DBR77, and Bartek Straszak, CEO at DBR77. In the second part of our panel, we're going to expecting a special guest, Mr. Maciej, CEO of Wielton company. So today we are going to focus on digital twin technology. We are focused especially on its functionalities. I mean, visualization, simulation, optimization, and digital transformation, right?
Many. Patience.
Okay. But before we start, let's see a short movie. So please sit back, relax, and watch.
With some very brief and short introduction to our meeting. The assumption is that more or less in the hour we would like to share with you very practical insights about digital twin, not only theory, what digital twin can do, but mainly what was done by our team with our clients. We would like to share with you what's the difference between the tools which are on the market and our solution, and why we believe our solution is perfectly fit for the current market expectations. And we would like to inspire you also with the most famous digital twin which exists on the market, which is of course delivered by NVIDIA. So I do hope we can find such movie, and if not, we will go and probably we'll be back to that movie. Bartek, it will be great if you can say a couple words about you as a short introduction, and maybe we'll also introduce ourselves, what we do, and what is our role in the organization.
All right, thank you. And my name is Bartłomiej Straszak, shortly for English version, call me Bartek or Bart. I'm responsible for operations in our Polish team, which means both sides, sales and also delivery, which means delivering the value of our marketplace, delivering the value of our digital roadmap, and delivering the value of the most important product, which is topic of today's discussion, digital twin. So that's the whole combination. That's why I'm here.
That's perfect. We still don't have the movie, so maybe just think a couple of words about you, what you do in our team.
A lot of things. So, well, firstly, I'm a business partnership manager at DBR77, and currently I'm providing a lot of issues and formalities connecting with a launch company in the United States right now. So that's the main subject, I guess. And a great goal for our team for the next few months, for sure.
Yeah, my name is Piotr Wiśniewski. I'm the co-founder of DBR77 and CEO. I'm responsible more for the marketplace and digital twin, but personally, I'm so much in that project that I'm really happy that I can be on that meeting. So maybe we'll go with first questions.
Exactly. So, the main part, the introduction to fundamental assumptions of the digital twin. So, can you explain us how this works?
Yeah, digital twin, which we deliver on the market for more or less like 3 years, as a couple main assumptions. First of all, we would like to be available for everyone. Yeah, we would like to share with you today what NVIDIA do as for sure the leader on the market, but we believe that their solution is crazy expensive and very complicated. So you need a lot of money, time, and technical support to launch such solution on the market.
And also resources.
Our assumption was that we can do it on the cloud. I will show you how easy it is. And then another thing is that you need like 2-3 hours before you will use it. Yeah, 2 hours of training is absolutely enough to start with digital twin. So we took the guys from gaming market and we asked them, hey, can you do the same story which you do with, for example, gamers, with the Sims game, and try to do it for manufacturing. So you will see that our digital twin is so easy to use in the regular work. Oh,
Yeah,
we have movies, so maybe
we
we'll
should
be
deep
back.
dive slightly, Piotr, in the terms of what does it mean, the digital twin, and what is going on, in terms of data and so on, because there is so much discussion about the digital twin in general. But I would say we had a lot of discussions with our clients where we need to establish the basic definition of it, because sometimes the expectations of digital twin are different. And I believe the unique value proposition from DBR77 digital twin is what you already mentioned. So we deliver the software which operates in cloud, opposite to what delivers NVIDIA, right? Where you need to have at least very powerful computer, which will probably cost like $15,000. But that's not the point. My main point is that our solution is operating on, I would say, the process level, right? Which is suitable for 80 to 90% of issues which are faced in current production and warehousing, which means that you probably don't need to have NVIDIA digital twin, because probably you will never use all the features that you've already paid. And this is the story which we explained with Dorota in the morning, that we need to start with something small. With every new tool, you need to learn, you need to grow, and then you need to add additional layers on top of that. So I think that's the key element for today's discussion, when we will move to deeper fundamentals and insights which we gathered and prepared for our guests. What are your thoughts on that, Piotr? Because I think
Yeah,
that
I think that you ask for something truly important, means definitions. I got the information that we have the movie, but before the movie, the definition, it's a really right moment, 100%. Guys, for us, digital twin is a virtual and mathematical, or graphical and mathematical representation of the real world in the visual version. So from one side, we have real world, like production factory or logistics center, and we would like to represent all 3D graphics in our digital twin. But behind that graphical stuff, we have a lot of math. And that mathematics present the processes and all tasks which are ongoing on the factory. And in that way, we would like to present the plant. And of course, in that way, we are able to do all of that stuff which we want to present today. Bartek, do you agree with such definition?
Yeah, exactly. So I would say our way is focusing on the simplification. So that's the key thing that I would love our guests to take away from today's discussion, that it's easy, first of all, to get on it, to adapt it, and to use it and to scale it. So because you can use whatever data you've got. If you do not have significant amount of data, it will be enough, even though, to visualize most of the processes that you will have. And obviously that will not be enough, but let's move on. Yeah, all right.
Yeah, let's move on, because everything is ready for this presentation. Let's go with the movie.
Great.
Can we advance?
Digital twin. The AI agents helping robots, workers, and infrastructure navigate unpredictable events in complex industrial spaces will be built and evaluated first in sophisticated digital twins. This omniverse digital twin of a 100,000 square foot warehouse is operating as a simulation environment that integrates digital workers, AMRs running the NVIDIA Isaac Perceptor stack, centralized activity maps of the entire warehouse from 100 simulated ceiling mount cameras using NVIDIA Metropolis, and AMR route planning with NVIDIA cuOpt. Software in loop testing of AI agents in this physically accurate simulated environment enables us to evaluate and refine how the system adapts to real-world unpredictability. Here, an incident occurs along this AMR's planned route, blocking its path as it moves to pick up a pallet. NVIDIA Metropolis updates and sends a real-time occupancy map to cuOpt, where a new optimal route is calculated. The AMR is enabled to see around corners and improve its mission efficiency. With generative AI-powered Metropolis Vision Foundation models, operators can even ask questions using natural language. the visual model understands nuanced activity and can offer immediate insights to improve operations. All of the sensor data is created in simulation and passed to the real-time AI, running as NVIDIA Inference Microservices, or NIMs. And when the AI is ready to be deployed in the physical twin, the real warehouse, we connect Metropolis and Isaac NIMs to real sensors with the ability for continuous improvement of both the digital twin and the AI models.
Okay, this was our, it was NVIDIA solution. It will be fine if we can change to my screen now and present what DBR77 delivered to client.
Great. So what's the difference between simulation of production line and the whole factory?
Yeah, this is a great question, because you can saw in that short movie that NVIDIA as well as DBR77 we approach whole factory. Yeah? In the previous generation of programs, what our competitors did, and they just do the same, they simulate the line. So it means that we can simulate the process, how material flow, we can see what is the times for every single station, and in the line is balanced. But in the previous world, we were not able to look at the whole system. I mean, the company, the production plant, on logistics center, the whole system. It means that we didn't take to the account any kind of analysis about material. So this is a huge shift, yeah? In the previous perspective, we looked at the process, how material flow. And now we try to look at the real stuff, like, okay, we have on gate some material and how the material flow through the organization. You know what is the biggest difference? In that way, we can look at the whole organization as a one system, because all of the processes, all of the line, all of the operations, stations, they are connected through the material flow. So this is a really huge, huge difference. Can I ask for my screen, for my computer? It will help probably a lot to discuss what we do. Or maybe I have, I need to share something. This is a time for another question, because I have to deal with my stuff.
Yes, so we are talking about process simulation in the factory, right? So what's the difference between animation and simulation?
What's the difference between animation and simulation? Bartek, would you like to try answer for the questions?
Yeah, let's me explain. I think we've seen that you were moving on within our digital twin, so it was okay. Yeah. So probably, yeah. Now you're switching to IoT panel, so it seems like it's working. So if you're ready, just take a hit and follow on. So that we can discuss it. But basically, the animation is simply a representation of a limited and defined in a specific manner task upfront, and simulation gives you opportunity to tune the parameters or to create alternative scenarios for that kind of animation, which gives you additional added value in terms of insights you generate during this simulation.
Yeah, that's this is truly huge difference, yeah? Because when we speak about the animation, like all others, let's say, deliver on the market at that moment, there is very simple process. For example, one cycle time on the flow, and we can look like 5 hours, machine is working the same way, and the results is quite predictable. But, you know, in the complex world which we exist right now, when, you know, the batches of the production are very short and there are a lot of interruption between all elements in the process, we have to find a way how to simulate. So we can change assumptions, first of all. Second of all, there are a number of diversions in the production, and then final results can be different. So this is so much important that we can automatically change assumptions, and then simulation will give you different results. And you can guess the different results means also a lot of data. So that's the huge difference between tools which exist on the market and our solution.
Oh, nice.
Or maybe simply speaking, just to add up, because I think that it might be too difficult for our guests. So simply speaking, animation is somehow unrealistic, because in the real world, we do not press play and we go home and the machine is working 24 hours a day. But in a real life, what is happening is we set up machine for one product, and then after a couple of cycles or number of cycles, we need to change something, or there is another event that is triggering additional actions to be taken, and that can be simulated. That is not animation. Yeah, then we are closer to real world examples with a simulation.
Yeah, that's the point.
Okay, I see now. So give me a few words and some tips how to build a digital twin.
Yeah, this is the question for that answer is what Bartek started 10 minutes ago. Yeah? First of all, we need 3D models. Yeah, so we understand how the process is organized, how the plant is organized, what kind of machine we have there, what kind of equipment, how many people. So we need 3D models which will represent all of that stuff on our plant. This is first point. Honestly, much easier than the second one, because second one is data. We need to understand first of all what is the typical cycle time for any object on our digital twin. I mean standard time. Standard time, many companies know standard time. Very often we also see that this is even that is the problem. Second thing is that we have to understand what was the deviation from the standard time to regular, real stuff in the past. And based on such deviations, we can make a prediction how the future will be imperfect. That's exactly what Bartek mentioned. You know, this is impossible that everything runs according to the plan. And this is also the case in such a complex system. Yeah? So we understand, first of all, what we have there, how the process flow. We need 3D models, and we need the data which represent how objects work. And in the perfect world, it would be great if we can know what is where in every single second. Yeah. So we need location, but honestly, at that moment, there is no technology on the market which can give such information to our system every single second. So we have to predict location of 3D models every moment in the plant. Bartek, did I forgot about something?
No. I would say there is a lot of possible technologies, but they're probably too expensive to have any practical impact these days. So we can imagine that we will place a lot of sensors, then we can track even single screw. But we need to take into consideration the cost of the implementation, and with our guiding principle to have it simple and affordable, even for SMEs. That's the way we need to use the software to boost that and to improve the lack of the speed which is presented in the hardware development, because these days software is far way faster than the hardware development.
Yeah, that's true. But do you have an estimation which technology will give us final result about the locations? Do you have your feeling about that?
I've got no feelings, sorry, but for me, it should be something between RFID, RTLS, but RFID is widely adopted, and RTLS or ultra wideband associations provides a better accuracy. But the limitation is that you need to have a lot of antennas, a lot of additional points to measure the distances and to create additional layers of network that can be covered within the factory, so that this gets expensive, and probably it's used only when you need to, because it's maybe hazardous, or it's required by law or anything like that. So it's very limiting the scope of implementation of that kind of devices.
I have a little bit different opinion. I believe that sooner or later it will be camera which is on the roof, and then from that perspective can look at the plant as I present right now on my computer. My team, if you can switch to the computer, it will be fun, and don't switch it back to us. And then you can recognize what object is where and what's going on there. Yeah, and analyzes things like that with LLMs right now is much more efficient than it was. And I believe that this is a technology of the future.
Yeah, that can be. That also answers my previous statement about that.
Wow, we are back.
Okay, so we are in.
Yeah, let's go with the question.
All right.
Yes.
I've disappeared before asking the question was asked, right? Perfect timing.
No, everything was messed, but let's not lose the time. Let's go back to the discussion. Okay, let's go.
Yeah, but we all started talking about the advantages of DBR77 digital twin software. So let's start it from this point, and let's talk about why this software is better than others.
What the software is better than other. Bartek, would you like to start with answering? Because the list is the hell long. Yeah.
So let's keep it simple. So again, the simplicity, right? And you can use it in your browser, so you don't need to have very well prepared or well established computer. You can run it on anything probably. I do not recommend using your phone because you will not see anything. But anyway, basically the story is that you can enter it with a very low entry problems, right? So you can use your own computer. You just need a typical internet browser, and that's it. You can start work right there. We've got a lot of tutorials. We've got AI navigator that will help you to make your first steps, how to navigate, to learn anything from scratch. So probably you can, as we speak, someone can just log in and try it from scratch, and it will be possible to do it within seconds, to set up the account and to start creating your own processes. Probably the next big thing is that again, the simplicity, right? Or we're trying to have all the options prepared in the back end of our solution, so that the client will not see all the difficult stuff we need to take care for them, so that it will be very simple. For example, when we talk about the right, but we know that 80 or 90% of our clients will use very deeply prepared and well-tuned models, so that they can benefit, because it doesn't matter if what kind of AI model it was used for optimization. That what matters is the outcome, and that's the biggest I would say benefit of work.
Okay, maybe I will add some very small point. First of all, when Bartek was speaking, I wanted to present how easy it is to build anything here. As you can see, we have a layout mode when we can change everything in layout, put walls, describe what is where. Then we have short, long list of assets. Assets for us means that we have 3D models. It's very easy to take it, just place whatever is needed. That's all. If everything or something has to be connected, has to be somehow in the communication between each other, it's done in that place. And then finally, we have animation mode, when we have, as you can see here, a long list of animations, and that animations can be used to describe what's going on, what people, machines, or robots, or trawlers have to do on the factory, and then just simply go and we have visualization, we have simulation, everything's worked pretty well. I would like to add another small thing, if I can take it. Good, guys, everything which you will produce there, I mean, in your computer, in your PC, you can see also in virtual labs. So just simply when you push the button save here, you can go to your VR and be there in the regular shapes. So everything is that size like in the real world, and we just simply visit everything. And on top of that, price, of course. Yeah, we don't need any special technology here. We need only our PC, and everything is there, and very easily, cheaply you can start. Means that you don't have to invest hundreds of millions of dollars. Just simply start with simple technology. Okay. It's convincing?
Yeah, sure, of course.
Okay.
So maybe any use cases that?
Yeah, maybe we'll start with.
So let's talk about the production environment. So can you tell us what you can do in this area?
Yeah, I prepared a couple cases, and I would like to share with you that stuff. So first of all, very often when we start with our clients, and I have to tell you that was also my experience in my previous assignment. I was the CEO of the company when we built 2 factories, and I remember very well that when we did all of the design at the very beginning, piece of paper, it was a couple shapes like that. The plan will look more or less like that with some flows. It doesn't work really very well because you cannot predict any kind of collisions. You cannot predict if people have enough place, if trolley with enough place and stuff like that. So what you see here on my screen, so if we can be back to my screen, I prepared for our meeting the plant, and I would like to very shortly present how easy it is to walk through that kind of solution. I hope everyone see my screen. So as you can see here, we have a warehouse area. In the warehouse area, we have incoming inspection. We have here some bags with material. We have all shelves. So we have all warehouse. It's very good because we can predict what is the space needed for warehousing in our factory. And then we have complete process. Here we have some molding area, we have CNCs which do another job, we have some maintenance area, and you perfectly know in any kind of factory we need the space when we have guys who can repair absolutely everything. Here we have some welding space when we do welding stuff. We have assembly, it's as far as I remember, 12 guys who do simple assembly, something like legitimization, quality control. Yeah, and this is a very good question because the material flow is normally recognized as the process flow is established. And in my case, look how easily it is to recognize. We have incoming gates here, incoming inspection. Then we have all storages here, so we can calculate what space is needed. And here we have flow of material, which is organized. What is very important here in our solution, as you can see, we have here regular spaces for intralogistic, and all intralogistic processes also presented. This is not only the case that we look at the stations and we do typical lean, like we calculate what is the OE in place. We also are able to check how the flow of material should be organized. This is a milk run, so we know the trollers which are running in the same cycle all of the time, or this is a Kanban when we can ask what kind of material should be delivered where and when. All of that processes can be presented here also. What is interesting when you look at my case, you should also recognize that there is no walls, no things like that. It's absolutely ideal world. So in the real stuff, when we do such design of the new factory, it almost never works. So we should start with layout analysis, with all kind of concretes or other elements which can be difficult for us, can make an interruption on our production flow. And such stuff is also great when we can do it on digital twin, because in that way we are able to avoid any collisions and any problems.
Oh, I see. So maybe let's go back to the math. And can DT help us to analyze production capacity?
Yeah, absolutely. It's good that we are in that place because look, we can see that every single operation, every single step in the operation is calculated. So we can see what is the time needed for any kind of analyze. So for example, how many minutes machine was stopped, how many minutes machine was working, how many minutes of any operator was done for his operation, for this job which deliver added value, or how many minutes he was walking, or how many minutes he had to wait, just simply like that. So in that way, we are able to recognize where are losses. When you look at the lean methodology, we always try to find one of 7 losses. The most important thing is the time which is lost by machine on the guy. So our statistics here can present it very, very well. So here, from the moment when we started our presentation, we did such kind of simulation. And look, we have number of reports. And look, on such simulation, every single process, can we put it on the screen? Every single process is calculated and every single object has his own analysis. So for example, in that process which we have legalization free on that line. We can see how many pieces was produced, what was the time, what was the regular cycle time, and we can go through every single step in the same analysis. Yeah, so for regular operator, that numbers doesn't speak so well. Yeah, but when you are a lean specialist or a process engineer, in that simple way, you can see every kind of information which we are looking for. But this is the first step, yeah, because the real stuff begins when we are able to collect data from the lines. So when we are able to put sensors, when we are able to use stuff like I presented here yesterday, when we can collect data about real efficiency, with such stuff, very easily, we can, first of all, know what is the real cycle time. We can compare the cycle time with the standard time. And also we know how machine was working, yeah, how many minutes, and when machine was stopped, why machine was stopped. And all of the data we can once again bring to the digital twin. And that is real data which will fit our digital twin. So as you can see, we can simulate, we can animate based on our assumptions in the real world, or we can really use real data, which is actually much, much more accurate.
I see now. So but you also refers a lot to the Lean 4.0. So does the specialist that work on DT can use also this methodology on ourselves?
Yeah, actually that methodology started with technology like digital twin. What's the case? Lean is like 70 years old. Yeah, after Second War, Japanese like Toyota, they had to find a way how to use the stuff which they had in the optimal way, and Lean history started. Lean became very famous in 19th last century after the Toyota World book was published. And we recognized that we can use other processes, we can measure them, and based on the data, we can find a way how we can improve them, how we can increase efficiency. But the issue was, or in the past it was not a problem, now it is a problem, that 20 years ago, 30 years ago, production batches were very, very long. Like when I was the CEO of Maflo, we started production of one part number Monday morning, and we finish on Friday, for example. So like 5 years, long, you don't have to change anything. In such way, it's quite easy to understand what is your cycle time, what is a changeover, what kind of losses you have. But in current life, almost nobody had production like a week. Normally, this is like 20 pieces changeover, 100 pieces changeover. In such world, it's very difficult to find a way how to optimize such processes. And digital twin and IoT, because we should look at the two technology together, work in that way that we are able to automatically collect the data, which is one point. In the past, it was done by people on papers, and such papers was used for analysis. Now we have number of sensors and other stuff to collect data automatically. That's first point. And second point, in the past, when we do value stream map, we can do that to like once per week or once per month. Now we have to do it almost every 10 minutes to calculate how we should organize our processes. And nobody can do it on paper. Yeah? So digital twin can help us with very fast and automatic simulation, which option will be the best for our job. So as you can see, we can automatically collect data and we can use digital twin for perfect analysis. But the key point is that we didn't find anything new. All of that stuff is a lean, which we were able to automatize in the technology which we currently have.
Okay, thank you so much. So it was really, clear explanation. And now I guess it's the time for our special guest.
I think so.
Yeah. So let's meet Mr. Maciej, CEO at Hilton.
Hello.
Okay.
Hi, Maciej. Very nice to see you.
Nice to see you too.
We had a number of technical issues, so I really do hope we'll finish our meeting before other stuff like that. We have prepared a couple of questions for you.
Okay, I'm ready to answer for you.
That's great. So, Maciej, can you explain us, is digital twin fit to your company's overall strategy?
Yes. Nowadays, the problem of limited access to the qualified staff forced entrepreneurs to looking for some solution how to make processes easier. That's why today we are looking some digital solution
how to improve our processes, to cut off some job stoppers, some bottlenecks. And to be honest, Wilton as a factory robotized our line since years ago, but still we have a problem to connect some machines, some line in one big body, in one organized. For us, the digital twin will be some locomotive to Industry 4.0, and to connect our robots to find the way how to improve our processes, how to stabilize our processes, how to remove all the blocking point in our processes. Why? Because we would like to be better. We would like to compete on the market.
See, so you probably agree with me that we can use DT to design factory, right?
Yes, difficult is to install the digital twins on the existing line, but the best solution is to use the digital twin as an option. Like if you are buying a car right now, you are taking some option for your car because something is better to you. That's why, in my opinion, this solution is a very nice tool in order to organize the processes before building the factory. You are able to check all the process. You are able to recognize all the blocking points in your processes, and if you face with this, you are able to mitigate this risk. And after that, you can design all the factory according to the process. That's why first you are building the process, and after that you are build the walls.
Yeah, this is absolutely the same like we build the house. I don't know if you had such. Yeah, actually you had such experience like building the house, and I remember perfectly when I did my first design of my house. In the middle of the night, I woke up and I said, "Wow, stairs are not in that place when they should be, because then I cannot open the door." And when you have very complex stuff like plant with all flows of material, machines, people, all legal aspects of buildings like that, it's very hard to predict everything.
Maciej, have you got any advice for manufacturing managers starting the journey with digital twin?
From my experience, what I can advise. First of all, sometimes we are not believe in such a solution like digital twins, because this is something what we cannot touch. That's why from my experience, I recommend to install such a solution for a first small line in order to show everybody that this solution can bring you some final effects, because this solution will show you all the blocking points on your line, and after that you are able to to improve everything. But we as a human need to touch the real solution and real benefits. And after that, after these exercises, you can implement this solution for other stuff, other machines.
And really interesting, Maciej, if you are aware that Wilton is one of the first players in Polish market who tried to and start with such. So we are really very happy that we cooperate with that case, because there is not so many brave managers as you.
Yes, we have some. What I mentioned a few minutes ago, we have some ambition to compete on the market. In order to compete on the market, we have to be cheaper. If you would like to be cheaper, you need to improve the processes. But this solution and digitalization is giving opportunity, to improve everything, to reduce the costs, and finally you can give the better price on the market. And after that, you can be on the top.
That's true.
Okay, Maciej, can you tell us also, what do you think? Can we see one day a plant operations system that manages all those production facilities in the factory? I mean, where machines, robots, humanoid robots, and humans collaborate seamlessly?
Strange question, I know.
Yes, and if we are looking on the history last years, how the world is developing, everything is speed up. That's why I can believe that if in few years we can see the factory which will be fully automated, fully autonomous, without people. We can only one boss who is steering all the processes from one places.
That's Maciej, if I can make short discussion here, because that is something which I had in my mind last couple of weeks, in fact, because now everyone speaks about humanoids, and when you produce BMW, probably you can make everything by robots, yeah. But even with your production, when the batches are much shorter, and there's a lot of interruptions in the process, probably sooner or later solutions like humanoids they will be there. And I also believe that the case that factories are dark, there's really no people, that's extremely rare, even in the future. So for example, when you look at numbers and the robotization density, you can see that South Korea, they have one robot per 10 operators, 1 per 10, and they slow down. It means that probably there's some density, which is maximum, and then there is no sense to put no robots generally. So I personally believe that sooner or later, somebody have to find something like a plant operation system, like we have, DOS in our computers. Yeah, when such system will tell to people, to machines, to robots, to humanoids, to others what they should do and cooperate. Because can you imagine that you have like 1,000 people and 500 humanoids on the same factor and they cooperate? What's your feeling about that? I know that this is futuristic, but
it's
maybe
a futuristic
not.
Yes, but it happened. I think it happened. It could happen because still the qualified labor force is not enough on the market. That's why we have to looking for the solution, and finally we have to find the system which will connect humanoids and robots with one ecosystem.
Yeah. And I think the digital twin will be the base of that, because in the digital twin, which we wanted to present today, you look at the plant as a complete system. Yeah? So even right now, there are no humanoids, or even right now, there's not so many robots there. This is the way how we can add another robotization and can make it cooperation seamlessly. And probably that is one of the biggest challenges right now, because look, on the market, we have number of suppliers of robots, of machines, of humanoids. There's a huge competition who will be the leader, but it doesn't matter if you buy from Tesla or from others, they have complete system for themselves, yeah? And somebody has to be on top of that and collect all of that stuff. And I personally believe that will be the role of digital twin.
Yeah. And I see some interesting thoughts on Bartek's space about it. Any conclusions?
Well, I would say this conclusion about dark factories, I would say this is quite limited to the use case, right? And we've heard about Xiaomi, which published their dark factory 2 years ago already. So it means that they are operating under complete automatization. So I guess they have some kind of digital twin to manage everything. And what's the catch there? It's the fact that it's a complete automatized factory for the smartphones. So this is electronics. Electronics is always highly automated because we cannot produce electronics with our hands these days, right? You cannot be competitive in the market if you use it manual labor force. So I would say we will see increasingly adapting those dark factories, but it will strictly depend on the type of products which we are producing. And there are some products that are more beneficial towards that. And this is also the case of 10 robots per one operator case. because if you will have an average upon a whole population of the products which is produced in Korea, then you will see those which will be highly customized, which cannot be robotized, and you will see those which are large in volume. For example, electronics, and we know in Korea there is a lot of electronics produced. So I would say it always we need to take into consideration what exactly we want to achieve and what's the motivation behind. And what Maciej said, they are aware that to compete in the market they need to be cheaper, and digital twin can help them with two things: not only being cheaper and also to catch up with the changing market faster. So this is the case of what additional benefits the digital twin can bring. It's also the optimization at the scale, because usually with typical optimization on lean consulting or whatever, you will have a lot of steps to finalize and to gather data, to process it, and to draw some conclusions. While on the other hand, with digital twin, you've got the data already in, and you can run it parallelly for many processes. And then you can select, okay, we start with this one because it gives us the best ROI, or we start with this one because it's important from strategic point of view. So I think that's additional thing also to this discussion.
I have prepared at the end of our meeting another movie, and I do believe we can launch that. The movie which was presented 2 months ago, Las Vegas, by CEO of NVIDIA about the digital twin. So I do hope we can watch it.
And for that is very clear. Everybody wants to digitalize the future of industries. There's so much waste, so much opportunity for automation in that $50 trillion of the world's GDP. So let's take a look at that. This one example that we're doing with Kion and Accenture.
Kion, the supply chain solution company, Accenture, a global leader in professional services, and NVIDIA are bringing physical AI to the $1 trillion warehouse and distribution center market. Managing high-performance warehouse logistics involves navigating a complex web of decisions influenced by constantly shifting variables. These include daily and seasonal demand changes, space constraints, workforce availability, and the integration of diverse robotic and automated systems. And predicting operational KPIs of a physical warehouse is nearly impossible today. To tackle these challenges, Kion is adopting Mega, an NVIDIA Omniverse blueprint for building industrial digital twins to test and optimize robotic fleets. First, Kion's warehouse management solution assigns tasks to the industrial AI brains in the digital twin, such as moving a load from a buffer location to a shuttle storage solution. The robot's brains are in a simulation of a physical warehouse, digitalized into Omniverse using OpenUSD connectors to aggregate CAD, video and image to 3D, LiDAR to point cloud, and AI-generated data. The fleet of robots execute tasks by perceiving and reasoning about their Omniverse digital twin environment, planning their next motion and acting. The robot brains can see the resulting state through sensor simulations and decide their next action. The loop continues while Mega precisely tracks the state of everything in the digital twin. Now, Kion can simulate infinite scenarios at scale while measuring operational KPIs, such as throughput, efficiency, and utilization, all before deploying changes to the physical warehouse. Together with NVIDIA, Kion and Accenture are reinventing industrial autonomy.
In the future, that's incredible. Everything is in simulation. In the future, every factory will have a digital twin. And that digital twin operates exactly like the real factory. And in fact, you could use Omniverse with Cosmos to generate a whole bunch of future scenarios, and you pick then an AI decides which one of the scenarios are the most optimal for whatever KPIs, and that becomes the programming constraints, the program, if you will, the AIs that will be deployed into the real factories. The next example, autonomous vehicles.
That's the message which I wanted to use at the end of our meeting. That's absolutely every factory, sooner or later, we have a digital twin with our small changes, maybe not with NVIDIA solution, but with our solution, because our digital twin do exactly the same. We're able to simulate all possible scenarios. We're able to collect the data. We are able to produce synthetic data. And based on that, we are able to train our MLs, which help managers with every kind of decision. So I truly believe that what NVIDIA do and what we try to do also in the same direction is the future of manufacturing. I know, guys, any conclusions?
I hope your dream will happen, and I keep across that everything will be on what we plan. And the future will be not so dark.
I also hope that sooner or later, I mean, maybe next year, or in 2 years from now, we'll present how Wielton with his digital twin increase her efficiency, and maybe we'll have also approval from the board to present the results of the projects which we are working on right now. Bartek, some thoughts?
Well, I think basically what we're trying to convey is that we need to be open for new technologies, and on the other hand, very pragmatic, what Maciej mentioned before, right? Digital twin is something digital, so start small, get used to it, and then scale it up.
So it was a very inspirational conversation, I guess.
Yeah, thank you very much.
Thank you so much.
And let's hope we meet next year and we'll present the, real different stories.